Hi, welcome to Codable. In this video, we'll be solving the question of middle element of a linked list. This is a Zoho Amazon interview question. Now, let's get to the problem. Here we are given a linked list as input. 1 pointing to 2, 2 to 4, 4 to 5 and 5 to 3. Our task in this question would be to find the middle element of this linked list, which would of course give us the result as 4. We have an obvious approach to solve this problem, which would be traverse this linked list using a loop. That would help us find the length of this linked list. After finding the length of this linked list, what we have to do is divide the length by 2, which would give the mid value of the linked list. So we have to traverse this linked list again till we reach the mid position. And once we have reached that position, all we have to do is return the value that is stored in that position. In this case, that would be 4. But we have a simpler approach to solve this problem, which would be fast pointer slow pointer approach. This approach involves 2 pointers, as we can see, a fast pointer and a slow pointer. To understand this concept, we'll be taking an analogy, and in that analogy I'll be racing with my brother. So let us go into the participants. Here we have me and my brother. I have a really fast car and my brother has a cranky car. So with that, let's move on to the track. So the track is a 100 km long straight line, and my car travels at a speed of 100 km per hour, while my brother's car travels at a speed of 50 km per hour. As we can see, the speed of the slow car, which is my brother's car, is exactly half of what the speed of the yellow car. We'll see why this is important in just a minute. Now let's begin the race. And the cars have started to move toward the finish line.
1 hour later.
As we can see here, I have crossed the finish line first and won the race. The thing to note here is, after an hour, where is my brother? As my speed was 100 km per hour, I would have completed the entire track in an hour. The speed of my brother's car was just 50 km per hour, exactly half of what the speed of my car was. So he would be stuck at the middle of the track. When I have reached the end, that is 100 km, he would be at 50 km. Now let's bring in the linked list to this example and see how they both are related. Here we have the linked list. So when I am at the finish line, that is the fast car at the finish line, which is pointing to the last element of the linked list or the null value. What we have to note here is, what is the slow car, that is my brother's car, pointing to? It is pointing to the middle element, that is 50 km as we saw here. So if we assume this yellow car, that is the fast car, to be a pointer and the slow car to be another pointer, yellow car to be a fast pointer and blue car to be a slow pointer, and one is traveling at a speed which is twice that of the other. In that case, when the fast pointer has reached the end of the linked list, the slow pointer would be exactly at the middle of the linked list. We are going to use this exact concept to solve this question. Here we have the 2 pointers. Blue color pointer denoting the slow pointer, which is traveling at a speed of 1x, that is, it travels node by node, element by element, while the fast pointer travels at a speed of 2x, which means it skips an element in between and jumps to the next element, like shown here. The blue pointer moves to its next element, while the red pointer, which is the fast pointer, skips the next element and jumps to the element next to it, which is 4 in this case. Now the slow pointer would move to the next element, which is 4 in this case, while the fast pointer would skip 5 and jump to 3, which is the last element of this linked list. Now the fast pointer is at the end of this linked list. As we saw from the analogy, when the fast pointer or the fast car is at the end of the track or linked list, the slow pointer would be at the middle element of the linked list. So the blue pointer, as we can see here, is at the middle element of the linked list, which is in this case 4. So all we have to do now is return the value that is stored in that position. So this is the concept that we are going to apply to solve this problem, and this will reduce the number of operations that we are doing directly from n to n by 2, which is exactly 50% more efficient than the original approach that we saw. Now let's get to GFG practice and code this logic. Now we are at GFG practice to solve this question. We are given a function called getMiddleOf, and that has an input argument of node star head, that is, the head node of the linked list is given to us as input. all we have to do is return the middle value that is being stored. And the structure of the node is also given to us. It contains the data part, which is an integer, and the pointer part, which is pointing to the next element, that is called as next. As we saw, we need two pointers, a slow pointer and a fast pointer, and both started at the same position as starting point of the linked list, which is given here as the head node. Now let's declare those two pointers here. The data type for this pointers would be, it is going to use the structure of this head node, that is node star and then the name of the pointer, which we are going to call it as slow and fast respectively. And both of these pointers are going to start from the beginning of the linked list, our head node. So we are assigning it to the head node. Again, we are going to have another pointer which is called fast, as we saw, and it is also going to start from the beginning of the linked list, so we are also defining that value to be head. So we have two pointers now, a slow pointer and a fast pointer. Both are starting from the beginning of the linked list. Now let's move on to the while loop part. So we have a while loop here and we need a condition to traverse this loop. So the condition for this loop would be, fast pointer should not be pointing to a null value. At the same time, fast pointer's next element should not also be pointing to the null value. Let us see why is that. Now let's assume we are at the element that is just before the last element. Now the fast pointer is pointing to this element, and as we saw, it skips the next element and moves on to the other element. So the next element would be the last element, but fast pointer skips the last element, would move on to the next element, but we have no other elements to go, right? So that would result in an error, but we do not want that error to come. So what we have to do is, we have to check two conditions. One, this fast pointer should not be pointing to a null value. At the same time, the next element of this fast pointer should also not point to a null value. Those two conditions would make this loop complete. So fast not equal to null. So this is the first condition. The fast pointer should not be equal to null at the same time, and fast.next should also not be pointing to null value, right? So fast.next is not equal to null. These two conditions would make this loop complete, and the thing that we have to do inside this loop is to increment these two pointers. The slow pointer is going to traverse this linked list node by node, so the increment value for that pointer would be just 1. But the fast pointer is traveling at the speed of 2x, so the increment value for that would be 2. So let's increment the value of the slow pointer first. So slow is equal to slow dot next of. This makes the pointer move to the next element, while we have to do the same process to the fast pointer but twice, because the fast pointer is skipping the next element and moving on to the other element, right? So we are doing the process of dot next twice, and that's it. This would make the fast pointer skip the next element and move on to the other element. So these are the two statements that are going inside this loop. When will this loop end? This loop will end when this fast pointer or this fast pointer's next element is pointing to a null value, which would mean we have come to the end of this linked list. That is, our car has reached the end of the track. What we have to do at that point, our slow pointer, in this case this variable, would point to the middle element at that point, right? So after this loop is complete, we can say that the slow pointer is pointing to the middle value. So all we have to do now is return the value that is being stored in that position. So return slow dot data of. As we saw in the structure earlier, these two pointers have two elements, that is, one an integer part, that is the data here, and the other the pointer part, which is the next that we have used here. So here we are returning the data part of this slow pointer, which would make this program complete. Now let's submit this code and verify our output. We have got the output as problem solved successfully. Today's try-out would be, what is the time complexity of the approach that we have used today? Please share your answers in the comments below. If you love this episode, please drop a like, and if you have any questions for us, please drop it in the comment section below. And let's see you in the next video. Until then, bye bye.